3. And what's the tangent of pi over 2 or 90? Undefined. So this is different than sines and cosines because we never ran into an undefined before. Okay? So once we get past that, this angle here, which is 2 pi over 3, still has the same reference angle as this one, pi over 3. So it's still going to be a root 3, but in this second quadrant, all students, only sine is positive. So these are going to be the same values, just all negative. So this will be negative 1 because that's still a 45-degree reference angle, and this will be negative root 3 over 3 because that's still a 30-degree reference angle. And then this will still be 0 because it's a 0-degree reference angle. So this gets us kind of through quadrants 1 and 2. So here's quadrant 1. Here's quadrant 2. When we go into quadrant 3, all the tangents are positive again. So this one has a reference angle of 30 degrees, so we're still going to be root 3 over 3. This one has a reference angle of 45, so we're still going to be 1. And this one has a reference angle of 60, so we're still going to be root 3. Which brings us through the third quadrant rather. And what's this? Undefined. And then as you go, this has a reference angle of 60, so it's still root 3, but it's going to be negative root 3 because we're in the cosine quadrant. Negative 1, negative root 3 over 3, and then back to 0. So what's different about the tangent function is we have undefineds. At the undefined values, there are asymptotes. So there are these dotted vertical lines that the graph will never be able to cross. We don't have points at pi over 2 and at 3 pi over 2. This is pi over 2. This is 3 pi over 2. We don't have points there because they're undefined. Okay? At 0, we have 0. At pi over 4, we have 1. So those are kind of easy to graph. These outputs aren't as easy to graph because they're decimals. But what is happening to these values? As we open up through our unit circle, what's happening to these tangent values? Are they growing or shrinking? Growing. And they're growing uncontrollably. Really, they end up going towards infinity. And then on the other side of the asymptote, we're going towards negative infinity. And at pi, we have an output of 0 again. So there's a point pi 0. And then we have this between the asymptotes. Okay? If we open this up backwards to like a negative pi over 6, where is our first undefined going in the negative direction? So I'm going back this way. Here, right? What angle is that? Negative what? Negative pi over 2. So we have another asymptote here. And this pattern just repeats, 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 repeats. So it would be the same over here. And where would our next asymptote be? Right. They're at the odd pi's over 2, loosely speaking, like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. And the asymptotes are going to keep continuing because we keep going round and round and round the unit circle and repeating these values. Totally different, right? Number 1, the domain is not all real numbers like it is for sine and cosine. It's all real numbers except the odd pi's over 2. All real numbers except odd pi's over 2. There's also, this is odd because it's not the same as sine and cosine. There's no minimum and maximum, right? It keeps going infinitely down towards negative infinity as we get closer and closer to this asymptote. So there's no minimum and there's no maximum. The range is all real numbers. Versus the range for like a parent graph sine cosine, it always has to be between negative 1 and 1. If I'm talking about positive versus negative, I'm just going to focus in between 0 and 2 pi. And this is positive from 0 to pi over 2, meaning above the x-axis, right? And again from pi to 3 pi over 2. I'm just focusing from 0 to 2 pi. Are we out of here in 1 minute or? Oh, God. And that's really because this is Q1 and this is Q3. This one's Q2 and this one's Q4. There is no midline. There is no amplitude. And the period is pi. This cycle repeats itself every pi unit. Now, is this graph symmetrical to the y-axis? Is it even? Is it symmetrical to the y-axis? No. If you flip it upside down, do that quickly. Does it look the same? So it's odd. It's an odd function.